So let's talk about our rational functions in relation to power functions. So looking at 1 over x here, that could be written as f of x equals x to the negative 1. So there would be our power function form. Something to keep in mind here is that we have this limitation on our denominator that it cannot be equal to 0. And what this does is it creates a vertical asymptote in the graph. So we're going to have this line that we cannot cross vertically. So if we go over to our graph here, that's what this blue line is representing right here, is that we cannot cross that line. Now there is a second line here that's going horizontally, and that's called our horizontal asymptote, but we'll talk about that more later on. For right now, vertical asymptote will be the important one. Now some key coordinates that we're going to have 1, positive 1, and then what we have is like when we're at 2, it would be 2 1/2. And then when we're out at 6, it's 6 1/6. So we're getting the x value and its fraction form as we're graphing to the right-hand side. As we get smaller between 0 and 1, we get larger and larger values. So what's happening right here at an output of 2, that's where our input is 1/2, our output is 2. So what we're ending up with are reciprocals of each other. And that's often what this function is called. It's the reciprocal function, where we're just flipping our function. So like at 4, that would come from plugging in 1/4, and we'd have an output of 4. Same thing over here, it's just with the negatives involved. So if we're plugging in a negative 1, we would get a negative 1. If I plug in a negative 1/2, I'm getting a negative 2. And then if I was plugging in negative 2, I would be getting a negative 1/2. So we're always getting reciprocals with this function. Now for domain, we have to skip over that vertical asymptote. So for our notation, we say we go from negative infinity to 0, but don't include 0, skip over it, and then start at 0, but not including 0, and go up to positive infinity. Then range takes into account that horizontal asymptote in this case, which again we'll talk about more later on, but same idea of skipping over 0 because we don't have any outputs of y equals 0. So our next function we're going to look at is 1 over x squared. So this is the case of where we could write it as a power function of x to the negative 2. And again, we're going to have the same vertical asymptote because we'd be solving that x squared cannot equal 0, which would just tell us that x can't be 0. So that would be our asymptote in this case. So for our domain, we're going from negative infinity to 0, but skip over it and then go off to positive infinity. And then for the range, since all of our values are positive, we're starting at 0 and then going off to infinity, but not including 0. So let's take a look at some coordinates we have here. And I'm just seeing that this graph is not good. Sorry. So ignore the grid part of it, and let's just talk about some coordinates we would have. So like we would have 1, 1, and we would have negative 1, positive 1. So remember, we're squaring our inputs and putting them in a denominator, which in terms of 1 doesn't do much, but just means our outputs will always be positive because we're always squaring. Now, let's say we plug in 2, then what I would end up is 1 over 2 squared, so it's a 1/4. So what's happening is this is shrinking down towards 0 a lot faster than our graph up above. Same thing if we had plugged in negative 2, it would still be a positive 1/4 because that negative 2 is getting squared in the denominator. Now if I was at 1/2, then where we would be is up at 4. So if I plug in a 1/2, we would end up with this reciprocal squared. So 2 squared, which is 4. And same thing over here with a negative 1/2. That negative 1/2 is getting squared, so it becomes positive. So it's just things are going to grow and shrink a lot faster when we have an exponent of 2. It holds true for exponent of 3, 4, 5. As it gets larger, those changes just occur so much faster. So these are the two parent functions we're going to focus on. So let's take a look at this first case here. So I'm seeing is that exponent of 2 on x in the denominator. So that's having me think that my parent function is an x squared. So with that, at this point, we're not going to cross x equals 0. I'm also going to imagine this horizontal asymptote at y equals 0. So there's our asymptotes. And then I would have like 1, 1, and negative 1, 1. At a half, I'm up at 4. At 2, I'm at a fourth. And I'll just kind of stick with those coordinates there. Okay, this 2 up in the numerator is multiplying on, so that's going to be a vertical stretch by 2. This minus 1 that's in the parentheses, that would be our shift to the right by 1. And then we're going to go up 2. So let's go with the vertical stretches. Just reading kind of left to right with it. So if I have an output of 4, a vertical stretch brings that up to an 8. Where I'm at 1, now I would be at a 2. And where I was at a 1/4, now I'd be at a 1/2. And then same thing over here, stretching those key points that I was using. Okay, there's our vertical stretch. Then we're going to move right 1 up 2, and I'm going to go ahead and do that at the same time. So right 1 up 2, right 1 up 2, right 1 up 2. And then same thing with these points. But actually, before I draw these next ones, something I need to think about is that my asymptotes are going to move too. And looking at this, I can see my vertical asymptote is I can't plug in x equals positive 1. So this vertical asymptote is moving over to the right 1. It doesn't matter that it moves up 2 because it's a vertical line, so that wouldn't really show up. But this moves our asymptote over. And then the same thing with the horizontal asymptote. That one is moving up 2, so that would now be up here. So those are where my asymptotes would end up. They follow the same rules with shifts, and stretches don't really affect them at all. Okay, so right 1 up 2, and then right 1 up 2, right 1 up 2. And we could just kind of make sure we have symmetry coming through, which looks good across our asymptotes. So now we just connect the dots as best we can to get this nice kind of curvature, and then stick within the bounds of those asymptotes. And then same thing over here. Getting closer to those asymptotes in the long run. Okay, one more example here. So I'm going to rewrite this a little bit. How about writing this as 1 over negative, I'm going to factor out the negative. So it would be a negative x plus 4. I'm going to write as negative positive x minus 4. That should get us to see all the transformations that we need to make. So this negative right here, it could be either. I want to make sure I'm saying this right. Yeah, it could be either over the y-axis or over the x-axis. It should result in the same thing. So let's just call this reflection over y, just since I have it in the denominator. But that negative could move out front, and then it would become a reflection over x. But either way, as long as we're only doing one of them. And then we're going to move right 4 and down 3. Okay, and my parent function is just the reciprocal function of 1 over x. So how that usually looks is we would have a vertical asymptote at 0, horizontal asymptote here, and then like a 1, 1, a 2, 1/2, a third, and then at 1/2 we're up at 2, at like a fourth we'd be up at 4, just if we want some extra points to play around with here. Let's just do the 1/4. Keep them kind of together. Okay, so we are going to reflect over y, which I messed up because I drew for 1/x², and we do not have the x². I should be down here in the third quadrant. Okay, a 1/2 we're at 2, and a fourth we're at -4, at 2 we're at a half, and 4 we're at a fourth. Okay, there we go. Okay, so reflecting over y, what I have on the left-hand side here is going to move to the right-hand side. So moving those points over. And then what I had on the right-hand side is now going to be on the left-hand side. And get rid of those. Okay, now we're going to shift right 4. So that's going to pick up our vertical asymptote over to +4. 1, 2, 3, 4. So here's where our vertical asymptote ends up, and then we're going down 3, so that's where our horizontal asymptote will end up. And then we could use that as kind of a guide of where our coordinates would end up. Like I would want to be on this second quadrant and fourth quadrant of these asymptotes. But I do like to just kind of double check my work by following our transformation as well. So like right 4, 1, 2, 3, 4, down 3, 1, 2, 3. And then same for that one. And then like that, where I would have, 1, -1, I go 1, 2, 3, 4, 1, 2, 3. So that's all lining up very nicely there, and then connect those dots for our lower portion. And I'm going to delete those. And then same thing over here with those transformations. We should end up right here. And okay, and just connect those nicely as best we can, and then erase our old work. And there we go. That's how we're going to work with our rational functions and their transformations.